Hello friends, so today we'll discuss the concept of hyperconjugation. Hyperconjugation is also known as no bond resonance. As you can see, I have written in brackets no bond resonance. So why it is no bond resonance, we'll just see when we discuss the example. So I have written several points which describe the phenomena of hyperconjugation, and we'll just discuss them one by one. So starting with the first, so what's the literal meaning of hyperconjugation? So hyperconjugation means excess or extended conjugation. So hyper itself has a literal meaning that it is in something is in excess. So here we have excess of conjugation. And why there is excess of conjugation? Conjugation means there is, and we have, with our previous knowledge of conjugation, it means alternate single and double bonds, and then electron delocalization happens because of that single and double bonds, as you have seen in case of several resonating structures. Now, what happens in hyperconjugation? The extended conjugation is because of the sigma orbitals or sigma bonds or sigma electrons, whatever you say. So it is because of the sigma bonds. What kinds of sigma bonds? Generally of the CH or CX type. And what do we mean by that? We mean that hyperconjugation involves the delocalization of sigma electrons which are in conjugation with pi electrons or with p orbitals that can be vacant or filled. That means in hyperconjugation what happens? There is an interaction between either sigma or pi systems or sigma and p systems. The p system can be vacant or half filled. So the conjugation is between sigma and pi or sigma and p. So how does it happen, and how can we write those structures? So that we'll discuss, just taking this simple example of ethyl carbocation. So we can write hyperconjugation structures for ethyl carbocation in a similar manner as we write the resonating structures. So how can we write? So like this. So I'll just to visualize the hyperconjugation structures, I'll just write the ethyl carbocation in its expanded form. So like this, all the hydrogens, showing all the hydrogens and the carbons with bonds. And this hyperconjugation structures are also shown by double-headed arrows, just like resonating structures. So how can we show them? So this is, now what is happening? So we have an interaction between sigma bonds and the pi or p. So here we have a vacant p electrons, as you can see, vacant p orbitals, that is described by the positively charged carbon. So we can just, what happens, this CH bond gets shifted towards the carbon-carbon single bond, and then the structure which arises is, this is the double bond, and here, so the positive charge on this carbon, this one, so that is gone. Now there is no positive charge here, no positive charge. Now what happens to the positive charge? So this bond is lost, rest of the bonds are same. In similar manner we'll write, and then what happens? This positive charge on the carbon is shifted to hydrogen like this. And then the next hyperconjugation structure is with the other hydrogen which is attached to the carbon next to the positively charged carbon. So like this, and again the one which has no bond, that carries the positive charge, the no bond, the non-bonded hydrogen. So like this, and in a similar way third structure will also be drawn like this, with the third hydrogen like this, H and H. So what is actually happening? The thing is that this positive charge is shifted onto hydrogen. Which hydrogen? The hydrogen which is next to the positively charged carbon. Now this we called as alpha carbon, and these hydrogens we call as alpha hydrogens. So the positive charge on carbon is being shifted to alpha hydrogens. So this is what is happening while we write the hyperconjugation structures. So this is how we write it, and this positive charge gets dispersed onto the alpha hydrogen, positive charge on carbon. And what kind of a system is this? So this is a system with sigma and p type of interaction, sigma p interaction. So this is how we write it. And as you can see, whenever the alpha hydrogen which carries the positive charge of the carbon, that has no bond between carbon and hydrogen, between the alpha carbon and alpha hydrogen. That is why it is known as no bond resonance. So it's a kind of resonance only, extended resonance with sigma bonds. So no bond resonance, because as you see, there is none of the positively charged alpha hydrogens have the bonds, because that bond is being shifted to the carbon, so between the two carbons. So this is how we write the hyperconjugation structures. Now hyperconjugation has several important uses, because as you can see, hyperconjugation gives explanation for the stability of the carbocations as well as the free radicals. That we'll see later on how that stability is being justified by hyperconjugation. And then also it describes why the alkyl groups are electron donating in nature. So electron donating nature of the alkyl groups is also explained by hyperconjugation. So this is a basic explanation of the hyperconjugation, and then further examples and further discussions and practice problems we'll see in the later slides. So hope you got some idea about the hyperconjugation concept, and hope it helps. Thank you.